Hello class, and welcome to lesson 2.2a, linear regression. Today our expectations are that we're going to be able to calculate something called the correlation coefficient using technology, as well as determining the line of best fit. Okay? So the correlation coefficient, the letter you want to remember for that is R, because we're going to find an R value. And regression is an analytical way for finding the relationship between the independent and the dependent variables. Again, this is two variable stats, so we're comparing how closely connected these two variables are. In this course, we will look at linear regression, which is finding the line of best fit. In our textbook, you'll see that they actually call it the least squares line of best fit. So that'll be on your formula sheet if you look at that, between two variables. Okay, so we can use the line of best fit to make predictions about the data. Okay, so that's the purpose of doing a linear regression, folks. There's two different types of interpretations or predictions we want. The first one is interpolation, and that means to predict within the data set. So if I have a scatter plot like this, ladies and gentlemen, okay, and notice you see there's a trend here, ladies and gentlemen, and I draw my line of best fit within the set of data. If I make an interpolation, that means I'm looking at data, for example, if I have 20 on my X, what's my Y value going to be? So you shoot from 20 on my X over to find the Y value, okay, or vice versa, you could start with a Y. Notice that's within the data set. The next one, folks, is called extrapolation. That's predicting outside the data set. So what happens, folks, is if I have a set of trended data, and maybe I'm going like this, okay, I do a line of best fit within my data set, but then as soon as I get outside, I'm going to draw a dashed line, okay, and this is to make predictions like in the future. This is why you have to do a census. So maybe our last data point was 2015. But hey, let's predict what will the population be in 2024 or something like that. Okay, so 2024, you go up to your line and across. So you extrapolate your line of best fit into a dashed line, and you predict outside the data point. You could also do it if the data's, let me show you another case. You could also, folks, if your data is just maybe in the middle, I've also seen it where you draw your line of best fit within the data, but you could even extend and make predictions in the early sense. So you could do it before the trend of data or after the trend of data. But notice in both cases it's outside the given set of data. I want to caution you folks that when you are asked to do a graph, make sure you check all the questions to see if they ask you to make prediction in the future. Okay, so be careful when drawing graphs. Okay, read all the questions to make sure that they don't ask you to make a prediction, for example, in 2024. Okay, otherwise you might run out of room on your graph. So make sure you read all the questions when drawing your graphs. All right, so folks, if you look in your formula sheet, here is the line of best fit. And prior to technology, ladies and gentlemen, this took a long time to get your accurate line of best fit. Okay, so basically, ladies and gentlemen, the only method we will use to find the line of best fit is to use technology to find this. Okay, it is way too difficult and onerous of a task to do it by hand. However, it is possible, and your great-grandparents or maybe even your grandparents who went to university may have done it. Okay, so that formula will be given to you on your formula sheet. Now, in order to use the technology to help you, ladies and gentlemen, I want you to either print this off or write this out, and you can use it for your tests. So print this sheet. Okay, you'll be able to use this button sheet on your unit test as well. You'll be able to create something like this for your final exam. Okay, so some of the stuff's going to look familiar from last unit. Reset calcs, you always start with that. Enter data in the same spot. This time you're for sure entering into L1 and L2 because L1 is going to be your independent variable and L2 is going to be your dependent variable. Okay, the important thing too, folks, to get the correlation coefficient is to turn the diagnostics on. So if you do your calculations and you don't get your R value, you got to double check to make sure you got your diagnostics turned on. And I'll go over that in my lesson as we go through this. Okay. And you're going to be able to get the graph, you're going to be able to get the equation, and I'm going to show you how to do the linear regression, which is the equation of the line. And I'm going to teach you, ladies and gentlemen, how to get that graph or that line of best fit to show up on your graph, as well as to list the equation. Okay? And you're going to tell the computer or the calculator how to do this all. Okay, and it's all from this sheet. So again, print this sheet off and make sure you've got it handy for you. All right, so let's take a look at an example, folks, and perform a linear regression using technology. Okay, so example 1, the data in the table below shows the measurements for the vehicle of weight versus mileage. Now mileage is, this is an American one because it's got miles per gallon, and we use kilometers per liter. Okay, so that's this is the imperial equivalent to that. All right, so question A says create a scatter plot. Well, ladies and gentlemen, to save you time, I just chose to use this here. Okay, when you're setting up your graph, don't forget that the independent goes on the X, which is your first part of your first column in your graph. So notice the weight's on the bottom or on the horizontal, and then your y-axis is your dependent. Okay, and that goes on the y-axis. Looking for our weights, ladies and gentlemen, notice we don't start with a low weight of car, like nothing in the hundreds, 200s, etc. So we're going to do what's called a break in the data. So notice here, folks, it looks like an N, but just break the data up so then you don't have to start at 0 and make your scale all the way to there. Okay? So we're going to take a look at starting our scale, and we can go up. So here's an example of a scale, ladies and gentlemen, and the same for mileage. Although mileage was low, we were able to start at 0 and keep working through it. Okay, so ladies and gentlemen, in the green, all these dots that are here, these are all these points. The one point that might be hard to read, folks, is the last one, just because of it got squished in the photocopier when I initially did this. So that is 2600, that last data point, if you can't read it. Okay, so plot all those on a graph and then use a straighter line than I did. Let's see if I can actually fix that. Put a straight line on. Okay, it's a little thick, but this might be a little better. I'm just going to adjust it a little bit. Okay, so that looks better there, ladies and gentlemen. Okay. All right, so do a straight line of best fit. Again, put your pencil down to get the trend first, and then try to get as many data points below and above on the trend. So looking at our graph, ladies and gentlemen, it looks, first of all, it's negative because as we go from left to right, it decreases. And it looks pretty strong because the data points are pretty close together. All right, so now it says determine the correlation coefficient. Okay, so that's the R value, and the line of best fit, which is going to be y equals ax plus b, according to your calculator, which is the same, folks, as y equals mx plus b, but your graphing calculator just uses a for representing m. Okay? All right, so how do we do that? Well, step number 1, use this sheet that we have. I'll pull my graphing calculator up, but before I do that, hopefully I can snapshot. Let me just grab my camera so I can snapshot some stuff. All right, so on our graphing calculator, you reset your data, or reset your calculator before you set the data in. So make sure you follow the steps that are on the sideboard. Okay, so I clear the list, I clear any equations, and I'll make sure mode float is set to 2. So that just means my data points will go in 2 decimal places. Okay, how do you enter your data? Go stat, enter your L1s for your independent, and under L2 you put your dependent values. Okay, make sure you double check to make sure that they're all in there accurately. Okay, once you've entered your data, okay, We are then going to, what it says in the instructions, we're now going to turn the diagnostics on. So this is something new. So if you look on my screen, folks, right near 0 above it's the catalog menu. So what color is it? On mine, it's blue. On yours, it's, when you do it in class, it's going to be yellow. So I'm going to press second and 1, just like the buttons say. Okay, and then I'm going to scroll down. Mine has a lot more programs on this than yours does. I need to scroll down till I get diagnostics on. There's an off and an on, so please be careful when you do this. Hopefully it's coming soon. Keep going. Okay, there we go. So there's an off and then an on. Notice the arrow is at the on. Press enter. And ladies and gentlemen, please stop here and take a look. This is not turned on. You have to press enter again. Once it says done, then you know your diagnostics are on. So that'll give you the R value that we discussed in last lesson. You know, if it's strong, weak, or medium. And again, that's a chart from your textbook to help you qualify that. Okay, so now we've got the diagnostics on, ladies and gentlemen. The next thing we want to do is to get this line of best fit going. Okay, so you have to tell the computer to turn the diagnostics on to get the data. So we go second y equals, turn it on, so press on, ladies and gentlemen. Mine says on, but if yours is highlighted to off, change it to on. And then we want what's called a scatter plot, which is your first type right there. So that's a scatter plot. Please make sure that L1 is for X and L2 is for Y, so you're matching them up. And then we press graph. So see everybody, we've got our graph there. Okay. Okay. So now what we want to do, folks, is we want to get that equation. Okay. So let's do our linear regression, and we're going to tell the computer or calculator that we want it right on that graph. Okay. So now you look on your sheet, ladies and gentlemen, where it says to do number 6, which is perform linear regression. Okay, so we go to stat, over to calc, see it says linear regression, which is number 4. Tell the computer where your data is, so it's in L1, so second 1, comma, L2, which is second 2. That's where we stopped last time, but now we're going to do a little bit more. So look on your calculator sheet here, and it says we want to press comma again. Okay, so not only do I want a linear regression, I want you to put it on the graph, and I want you to put the equation into Y1. So that's why we have to go find the vars button. So vars is right below your down arrow. Okay, scroll over to Y vars. We want to have a function, and we want the equation to go in Y1. Okay, so it looks like that. That's beautiful, and then you're going to press enter. Okay. And ladies and gentlemen, here is your screenshot. I'm just going to grab it quickly. Snap that. And I'm also going to go to my graph. Okay, notice there's my graph. So I'm quickly going to snap that if I can. Bring it over. Okay. And then, ladies and gentlemen, if you press y equals now, there is your equation of the line right there. Okay, I'm just going to move the arrow down so that I've learned this when it covers up the negative. I can't see it when I take a snapshot. Okay, so that's all we need to do on the graphic calculator. Let's transfer it now to our lesson. Okay, so here we go. We've got our equation of the line, ladies and gentlemen, which is y equals. So I'll put that in here. So you can write down here. Y equals negative, please, ladies and gentlemen, put a 0 in here, 0.01x plus 60.14. Okay, so it was there as well. If I just move this graph over here with the other graph, notice here, folks, they also gave you the equation here. You just had to substitute them in. Okay, so what do we know here? A is negative, which tells us, guess what, our correlation is negative. But let's take a look at the correlation coefficient. Okay, so it's the R value that's right here. So R equals negative 0.92, okay, which proves that it's a what? Negative, and it's strong. So it's a strong negative correlation. Okay. And folks, we've got the line of best fit either from putting in the equation or from just taking the A value, subbing it in, and subbing in the B value. Okay, I'm just going to write this out a bit better because it doesn't look very good here. So we're going to go y equals negative 0.01x plus 60.14. Awesome. Okay. Now it says use the line of best fit to determine the mileage of a car that weighs 3,500 pounds. So we could use the equation first, and then I'll show you how to use the technology. And these are going to be a little bit off simply because of, remember the line of best fit is just an estimate, right? Okay, so let's take a look, ladies and gentlemen. If it weighs 3,500 pounds, we're going to sub x equals 3,500 because it's on our x-axis into our equation. So we're going to rewrite the equation and go y equals negative 0.01, sub in the 3,000 for x, and plus 60.14. Use your calculator, plug that in, you should get y equals 25.14. Okay, and that's the mileage. Okay, so therefore, mileage is 25.14 miles per gallon if car weighs 3,500 pounds. Just missing my units there. Oops, sorry. Okay, that's one way. The second way, folks, is to use a graphing calculator. So let's go show you how to do that. Now, there's a calculate menu button right beside trace. So see trace, look above it. I'm going to go second in trace. Okay. And then I'm going to enter the value in. So see number 1 says value. I'm going to press value. And I'm going to go 3,500. I'm going to plug it in. Press enter. And it's going to give you 25.14. Now this one was exact, so that was good. So let me just quickly snapshot that, if I can, to bring your technology in. Bring it down. Okay, so that's another way you can find your answer for that one. Okay, next one says, I just move that up. Okay, next one says, find a vehicle weight that averages 20 meters per gallon. So what we're going to do is, instead of subbing in for x, we're going to sub in y, because that's your dependent variable. So we're going to sub y equals 20 into our equation. So we're going to go 20 equals negative 0.01x plus 60.14. Let's rearrange that. So I'm going to bring the 60.14 over, becomes negative. Okay, so we're going to end up with, on the left side, negative 40.14 equaling negative 0.01x. Divide both sides by negative 0.01. Okay, and you're going to get that x equals 4,014. So therefore, a 4,014 pound vehicle will have a mileage of 20 meters per gallon. Okay, now we can do this using technology, however it's going to be a little bit different. Okay, so for using technology, when I go over to do that, okay, because we can sub in for x and not for y, we have to do a different strategy. So I'm going to go to y equals, and I'm going to go to y2, and I'm going to put in another line. So I'm going to sub in the y value, which is 20, which means I'm going to put in a horizontal line. So if you look on the graph, see it's there, ladies and gentlemen, and now we're going to find the intersection point where those two join. Okay, so again, that's in that calculate menu, which is second in trace. Okay, look for number 5. It's the intersect button. It's going to say first curve. Just make sure it's on one line. Second curve, make sure in the second. Press enter to guess, and press enter again. And ladies and gentlemen, you have your answer here. And again, I will transfer that over. And again, you can use technology. You're just going to have to specify on your test how you got your answer. Okay, so let's bring that over and bring it down. All right, ladies and gentlemen. So this is technology. It's the best way to use, best way to find the answers is to use technology. In class tomorrow, you'll be doing page 169, numbers 5 to 7, and page 180, 1, 2, and 5. Okay, and hopefully you'll be using the technology, getting really used to it. I want you to be comfortable with the TI-83s so that come test time, you can use it with ease. All right. Have a great day, folks. And again, as always, come see me if you need any help.